Good morning, dear students. I, Dr. Kumar R, Professor and Head of the Department of Computer Science, PG, Christy Jenty College, Bangalore. In this lecture, we are going to see about tree-schema architecture of database management system. The main topics covered in this video lecture are tree-schema architecture and data independence. Before going in detail about the tree-schema architecture, you should have a thorough knowledge about what you mean by schema and instances. The simple definition of schema specifies that overall design of a database can be called as a schema. That means the brief distribution of a database. So when you say brief distribution of the database, this distribution also includes the definition of a database structure, its corresponding data types, and also the constraints on the databases. And the instances at a particular time, what is the current state of the database is called as instances. So as we said, schema is for overall design of a database. Based on the schema, the tree-level architecture of a database systems are defined. The tree-schema architecture defines the DBMS statistics of the program independence as well as how it supports the multiple views of the data. So the program data independence, once we'll see the architecture of the DBMS, then we'll see in detail about the program data independence. So the tree-schema architecture has three levels. They may be called as internal schema, conceptual schema, and external schema. These three schema are very, very important, which defines the overall design of a database, DBMS, and the internal structure. Okay. The first we'll see what do you mean by internal schema. As I said earlier, internal schema means the design of a database. The internal design of a database. That means at the internal level to describe how the data should be stored in a physical storage. Okay, that is to describe the physical storage structure as well as how to access the data, indexes, as functions, in which part of the memory is stored, how to fetch the data. Yeah, all the designs are given by the internal schema. And this typically uses a physical data model. As you know, there are different types of data model. The internal schema is based on the physical data model. The second important schema is what we call the conceptual schema. The conceptual schema is to describe the structure as well as the constraints for the complete database for the community of the users. What do you mean by conceptual schema? When you define a database, for example, you take a data definition language. So data definition language defines a table as well as what are the data types, what are the data you are going to store, the corresponding data types, as well as if there are any constraints. This information is defined in the conceptual schema. So it is like you are going to give a structure for the database. Not only structure, you are going to define the constraints as well as the data types and everything. For example, in SQL, structured query language, we are using a command called as a create table. The create table name followed by the field names. That information can be considered as an example for the conceptual schema. And this information, whatever information you are going to store, you are going to define in the concept schema should be defined in the data dictionary. Data dictionary, there should be a mapping between your conceptual schema as well as the internal schema. Then, what is the third level? Third level is what you call the external schema. Okay. External schema means what the user viewed the data. Whenever you are going to define the user, there will be some users will be using the database. Either it is a standalone user, or it may be a sophisticated user, or a program designer, or anyone. They want to use the database from the external view. Maybe a layman or maybe a teller will be using the database. So that is the external view of the data. The diagram specifies indicates the three-schema architecture. We can see that we have the external view, conceptual view, as well as internal schema. The external schema can also be called as a view level or user level or external level. Okay. And the conceptual schema can also be called as a logical schema, where you are going to define the logical design of the database. And the internal level defines how data is stored in the databases, in the stored databases. So in order to have a mapping between, we need a mapping between all these levels. So there will be a mapping between the external and conceptual mapping to fetch the data, what the user needs. And also the user view is a multiple view data, as we defined earlier. This three-schema architecture defines multi-user view at the same time. So it is not necessary there should be only one user will be using the database at the same time, or viewing the database at the same time, or storing the data at the same time. So many users may use the database concurrently at the same time. So only we have a multi-view database. So the end users will be using the databases using the external level. They may not know actually how the data is stored or how we are going to fetch the data. Simply, there may be a teller in a bank who will be using the external software or interface to access the data from the databases. And second level is what a conceptual level. It may be a database programmer or DBA will be using this conceptual level. It says, okay, what data should be stored? What data should be stored? That is a conceptual schema. So for example, when you write a C program, you are defining a structure. In the structure, you are going to give the name of the structure, as well as you are going to give the, what are the members of the structure with the data types. Similar like in DBMS also, you are going to create the structure as well as what data should be stored, what is the data type of the data, the size, the constraints, everything you are going to specify. That is defined in the concept schema. The internal schema is how physically the data is stored. So whenever a user wants the data, he approaches application program, uses application program or an interface to access the data. So once the request has been made, the conceptual schema verifies the syntax and the data validity and whether the data is available or not. Based on that, it requests the internal schema to fetch the data. The data structure stored in the internal schema will search the data and fetches the data, and it is passed to the user through some application programs. This is the way how the tree schema architecture has been defined. Now, it is not only you should know about the tree schema architecture, but also you should know the important concept behind this tree schema architecture is the data independence. One of the property of database is here, what we call this data independence. So the program data is not dependent on a program. Okay, it is independent of the programs. Any application can use the data without restricted to a particular application program. So what do you mean by data independence? A simple definition of data independence says that the ability to change the schema of one level without affecting the schema of another level is called as a data independence. What do you mean by schema? Already told, the design of a database. If I am able to change the design of a particular level without affecting the schema of another level, it is called as a data independence. So based on the three schema, what we have, internal schema, external schema, as well as the concept schema, we have two types of data independence. The first one is called as a logical data independence, and second one is called as a physical data independence. What do you mean by logical data independence? Logical data independence indicate the ability to change the concept schema without having to change the external schema and the associated application programs. And for example, you are going to change the structure of the database, and anyway, the external user will not have any impact on that. So that is called as a logical data independence. What do you mean by a physical data independence? Physical data independence indicates that you can change the internal schema without changing the conceptual schema. Okay, for example, you are changing the file structure from one method of representing the information to another method of representation of information that will not affect the programs. Okay, for example, as per the information given, the file structure reorganized or new indexes are created to improve the database performance instead of old one. So changing the memory or changing the file structure or changing the indexes, and if you are not going to change the logical data schema, then it is called as a physical data independence. Okay. So these two topics are very, very important. One is called as a tree-level architecture, which defines the schema of the databases. And next one is based on the tree-level architecture, we have a concept called as a data independence, that is ability to change the schema of one level without affecting the schema of another level. Okay, though there are two types of data independence, logical data independence and physical data independence. Okay, so in this lesson, the three important topics you want to remember is one is what do you mean by schema, what is here data instance, then what do you mean by a tree-level architecture, the diagram of the tree-level architecture, and what do you mean by data independence? What are the two types of data independence? And also another important thing is how you are going to map between one level to another level. Okay. Thank you, students. If you have any doubt, you can always mail to me. Thank you very much.